welcome to my solar system project thing. First thing about a solar system, it's star. Now, my star, Gamma Velrum A. And A because it's in a quadruple star system. But you'll find that it's the most interesting out of all 4 stars, and most other stars, because it is what is called a Wolf-Rayet star. Means it's basically a big quirky. What are some things about it? Well, it has 9 solar masses, and its radius is 6 times that of our own sun. It has a luminosity of 170,000 lumens, and it's an O-class star because its surface temperature is around 57,000 degrees Kelvin. What's going on in the core, though? Well, as we can see here, its core has a lot of iron, which tells us 2 things. It's pretty close to, and it's definitely not fusing hydrogen anymore. Probably moved on to helium or any of the other elements in that chain, because it's estimated that it's 3.5 to 5.5 million years, and it only has 1 million years left. So it's pretty close to dying. Now, the terrestrial planet. Its name is Achilles. Now, what are some characteristics about Achilles? Its diameter is 4,834 kilometers, and it is 412 AU from Gamma Velrum. What about its days? Well, one day is 410 Earth days. It's spinning pretty slow. But what about that giant path? That is 412 AU. That's more than 10 times the distance Jupiter is from our sun. So how long does it take to do that? Well, it's moving at around 20 kilometers per day, meaning you walk faster than this planet, meaning it takes more than 54 million years for this planet to make one orbit around. Now, onto the gas giant. Its name is Patroclus, named after the childhood friend and wartime companion of Achilles in mythology. So, pairs of names fitting for both planets. Now, what are some characteristics about this planet? Well, it's pretty big. It's 171,000 kilometers in diameter. And it's only 32 AU from Gamma Velrum. Now, you may ask yourself, hold on, that don't make no sense. And that's based on the principle that when a star starts fusing, it pushes out the lighter stuff way further than the heavier stuff. So why is the terrestrial planet way further than the gas giant? Well, this is a phenomenon called planetary migration. What is planetary migration? Well, it's when a gas giant moves from its place way out to way close. It's a phenomenon that we see in a lot of solar systems, and it would have happened in ours too. Jupiter would have moved in and gobbled up all the planets on its way to the sun. If it weren't for the big honcho himself, Saturn, coming in clutch and not letting that happen. So thanks, Saturn, for not just standing there and looking pretty. But as we can see in this solar system, there are no other gas giants to stop Patroclus from just moving toward the sun. But what are some interesting characteristics about this, though? Well, for one, it's pretty hot because it's so close to such an outgoing star. This means that it was probably smaller when it was out further, but as it got in and started heating up, gas expands when it's hotter, so that's how it grew to such a size. What about its days, though? Well, similar to Earth, it's around 24 hours. Pretty nice. What about its years, though? Well, 1 year is 36.4 Earth years. That means it has to be moving at around 2 million kilometers per hour. That's almost twice the speed of Jupiter. Alright, well, now we've also got an asteroid belt. Now, its range is around 417 to 419 AU. And its composition is most similar to terrestrial planets. It's also got a dwarf planet. Now, this dwarf planet is appropriately named Emma. There's no reasoning behind it. Alright, well, what are some characteristics about Emma? Well, for one, its diameter is around 2,000 kilometers, and it is 417 AU from Valromé. Has a surface temperature of around negative 210 degrees Celsius. Pretty cold, meaning it has like a layer of ice around the planet. As you can also see, it's pretty solid on the inside, and it's kind of pretty similar to the composition of the terrestrial planet Achilles. And because they're so close in distance, it's hypothesized that Achilles was once part of the asteroid belt. It was a dwarf planet like Emma, but for some reason a collision, probably, is what took it out of its orbit. This could also explain why Achilles is so unbelievably slow. Its rotation speed and how fast it travels would both be affected by an impact. Emma, though, she seems pretty good. With 392 billion kilometers to cover in its circumference, it does that in around 2,500 years. That's pretty fast for such a distance. Now we've reached the very edges of the solar system as we reach the Kuiper Belt. Now, the Kuiper Belt is really far out. It ranges from 490 AU to 514 AU. And its general composition is different compared to that of the asteroid belt, and it's more frozen volatiles than solids. Meaning it's things like hydrogen, ammonia, methane. So we can tell the gas giant probably originated around here and migrated inwards. Additionally, in this range we have the asteroid Emily, and its furthest point is 502 AU. Pretty far out. So that means it's around 75 billion kilometers out. And its closest point is actually a little bit further out than Patroclus. So it's closer than most things in the solar system. And its orbital period, it takes around a total of a little bit more than 6,000 years to complete one full orbit. As we can see here, though, we have the nucleus, coma, the gas or ion tail, and the dust tail. Alright, that's my solar system. I tried. And Mr. Lin, if you could give me a couple extra points, 1 or 2 even. I've had this light strapped to my back from duct taping for my bag. So I've done a lot of work. 1 or 2 extra points, that's it. So yeah. I'll see you. Peace out.